Testing, testing. Hey, there we go. All right. I'm still going to check on it just a moment. Properties, crisp, fine. Crisp now seems to be connected to the headset, and OBS is connected to it. Good morning, 715209. How are you? All right. Well, we're going to hop into it. I looked into um, using GStreamer for kind of cleaning up some of the buffering that we see here on the stream. Now, GStreamer is interesting in that you can create these pipelines. You can do quite a bit with it. And good morning, Arksy. Um, but a lot of GStreamer, if you're not doing anything dynamic, like we wouldn't be doing anything dynamic, switching scenes, moving things around, whatever it is, you can just set up a script and just run GST init and give it stuff, give it the config and just run with it. And I tried to configure something yesterday, and much to my family's chagrin, nothing ended up working, and it took me forever. Um, but we did level up our characters for the next D&D campaign. Um, but we're not going to use GStreamer. We're not going to do that. We're going to go use something else. We're going to write code, and we're going to inspect packets and read timestamps, and just go from there. So for those that don't remember, we are creating a couple little buffer tools to help with the dropped frames on the stream. So we're going to be using OBS and its TCP, its other functionality here. I'll pull that up on screen. So in OBS, we're going to be sending to a socket instead. We're going to be using FLV as a container format. We're not going to be inspecting the content inside the containers. We're just going to be looking at the wrapper. We need to know when the packets are supposed to be going out, so that we can properly delay packets going out by 5 seconds or however long. So we're going to be looking at the FLV format. Also, we're going to look at probably some hex dumps. Oh, you know what? We might be able to look at some Wireshark for this too. Do I have Wireshark? Wireshark. Oh, we do. Look at this. We just bring it on screen. So we'd be using loopback mostly. I'm going to add a filter. So this is going to be, this TCP destination port is going to be equal to 45321, something like this. And then if we fired up, just let's say netcat locally. Netcat-L on 45321. And we're going to pipe that to dev null. Permission denied. Whatever. Okay, just dump it to screen. That's fine. And we're going to hit the button in OBS. So we'll start recording button. All right, unspecified error occurred. Great. Does it know what kind this is? Ah, look. So we've got our TCP connection getting set up. Okay, that's all fine. Then when we get down to this part. I wonder why it died. Why did it die? FLV. Protocol preferences. I'm pretty sure we can choose a protocol somewhere in here. It's been a while. Decode as. Hmm. Oh, that's not for this. So we have like HTTP, etc. But I'm not seeing like an FLV in there. I thought that this had things hmm, for video. Maybe it's a plugin. I don't have that plugin set up. All right. Anyhow, so it starts with FLV on metadata duration. Okay, lots of buffering in here. We have some text, width, and height. Ooh, video data rate. Interesting that they're using plain text in there. Now, let's say we do this again. And why did netcount not output anything? Something's wrong there. It could be that I had something already bound to the port. Okay, I killed some stuff off. Let's see. There we go. Now it's doing it. Come back into Wireshark. Right click, follow this TCP stream. All right. So we can see lots of little packets coming through. Right. And this is basically what we're going to be capturing and then forwarding on. What is the structure? What is the structure? Is this FLV? Is it something else? I'm going to kill that. I think we've got enough data in here. Oh, interesting. Okay, this is where it starts, FLV. Now, what did OBS think of that? I do not think it cared. It seemed just fine. All right, let's pull up some docs on the format. I'm going to kill a bunch of these off. Close multiple tabs to the right. Goodbye tabs. You should try that. It's very freeing, very cathartic. All right, Flash video file, FLV file format. I think Wikipedia has good enough. Encoding. All right. So this is the first bit here. So you have the header, the version flags, header size. Okay, and then we have the packets. Payload data. Okay, good. Payload size. Size of previous packet. Ooh, that's interesting. Let's get some of this wired up. Used to skip a newer expanded header. All right. lib.rs. There we go. Mod FLV. Let's just call it header. Signature version flags. NATURE signature version flags and header size. Okay. What are the types? We've got 3 bytes. Version, it's a U8. Another U8. And the header size. UN32, big Indian. Big Indian. Okay. So here's our main function. Read incoming packets. All right. We're just going to skip the header. I don't think there's anything that we can really do with the header other than verify it. But other than reading this and skipping the header size to get to the packets, I think that's what we're going to do at the moment. After the header, the file is split into packets called FLV tags, which have 15-byte packet headers. First 4 bytes detonate denote the size of the previous packet/tag, including the header without the first field. Agent seeking backwards. Oh, that's interesting. So if you had a stream and you wanted to jump backwards, you could. Hmm. All right. Previous packet size, U32. Uint 24, Big Indian. Okay, we'll encode that in a U32. Same there. Stream ID. And then the data. Okay. Now, should we be using the Tokyo utils for this to just speed this up, or do we just do this by hand? I'm leaning towards by hand this morning. What do we want to do with the payload data? This is kind of packet header, stream header, file header, whichever. These both need to be pub. All right. Test module, test, stream header. Now, how do we want to use this? We have bytes here. Copy bytes as, ooh, do we use hex? What's it? Okay. Raw binary. Let's just do a hex dump. Okay, what do we get? Ooh, lovely. It's interesting. I actually want that not in hex, but as, let's say, as raw binary. What do we get for raw binary? Just a blob of binary, isn't it? I can't even paste it. Sorry, I just saw the YAML. Um, all right, we'll use the hex dump. Each one of these has to have an OX in front of it, doesn't it? Okay, there's that. Now commas. Okay, let's fix up the last one again. Data is going to be equal to a vector. This is a vector of UIs or just an array. I don't care. Vector will work though. Okay. And this is where you would typically use the stream utils. No. I mean, the headers, the size is in a strange place here. So we would ask it, do you have enough space? Do you have enough data for this? Now, these are likely going to be as bytes, the actual bytes type from the bytes crate here. Because we could do like a stream header try from its data. And we could do that only if correct, or if you had an incorrect set of masks. Yeah. Okay, try from. slice. Try from this slice. You know what? We're going to go with lifetimes here. Then the signature is always that. So if, no, we don't need a lifetime. We're not going to have a reference to those bytes because we know what they are. We can actually get rid of the signature here. And if try from fails, it's because that didn't match. That's strange. Oh, come on. Cannot find trade try from. Where is try from? Standard convert try from. Missing error. That. All right. All right, in this error, we're going to have some variants. One of them is going to be that the stream header is invalid. Invalid stream header. Probably the same thing for the packet header. I don't know. Is there stuff that we can validate on there? Maybe. Maybe if it knew that if it was a little more stateful, the FLV parser. But in terms of just parsing the packet, I don't think it matters. Oh, it's just a what? I know. You want display as well. No, 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 we're not doing that. The standard format, FMT, just FMT. Display takes. Oh, just format with the formatter. The standard format result? Yes. Needs to be a mutable reference to this. There we go. All right, now here, when we go to parse it, let's, is that, that doesn't look right to me. Is that sufficient? And how much data do we need for this? That's 3, 4, 5, 6, 7, 8, 9. 9 bytes. Do I want to say it's less than 10? Less than or equal to 9? No, less than 9. Otherwise, we construct the values. Okay. Hmm. Version, flags, and header size. What? Oh, this has to be a reference, a slice. We'll subslice there. ASCII table. Silly thing. All right. F 70. L 76. V, capital V. I was looking at the lowercase. 86. There. All right. Okay. Now version, it's just U8. So this is value 3. Flags is going to be equal to another U8. Hmm. Now this is a big endian here. From BE bytes. You know what? I'm actually going to kill this, the audio there. Expected array. Well, we could copy that into an array and then give it to this. That seems a little wasteful. What else could we do? Slice as pointer, line 2, chunks. Whoops. Hmm. Array coerces to slice. I mean, we could just say it's these four things like that. That seems wasteful. Yeah, it takes ownership of that. Try into? Oh, interesting. Already checked the size on that. CSC has not been behaving at all this morning. Okay, so the try into works. All right, so we do the slice here. Try to do the try from. Let stream header equal to that. Let's see. I just want to debug stream header now. Oh, nice. Invalid stream header. Oh, you can see it. It doesn't begin till down. What did we copy in here? This 46 4C. Is it there? This go away. Still no, huh? FLV is right there. I think what we ended up doing was copying the entirety of this. So it's probably from the very beginning, the 02 00045. Yeah, technically I don't want that. That's going to get stripped off. Wireshark gives that to us, but we don't need it. So it failed this check. Oh, this should be equals to. I thought it would do the size check on that. Oh, interesting. Okay. Line 47, we have a try from slice error. 47. Does not look correct. So we have FLV. 0105. What was the 01? Version. Okay. Only 01 is valid. Okay. Stream header signature. Let's see if we can say this is a U8 and that there are 3 of them. What is the next error? I'm just gonna write that whole thing out. Actually, hmm. Let's make it longer. Okay. There we go. Now I have to provide that information. Okay, I'm gonna leave the flags. Header size we're going to leave as well. All right, now this one we will assert equals. Now what was it? Flags. Excuse me. Hey, Dev for Fun. Good morning. Why have I selected Rust over Golang for server? Rust can go more places than Go can. So if I want to do how long a variable lives. Having done Java and C and Erlang and like all these different languages in the past over my career, Rust solves these problems up front for me. The compiler just checks these, so I don't have like these really hard to track down bugs later on. Yeah, I kind of started out as like a web dev and a C engineer, and so it just it just fits with me. Yeah, you're welcome. Payload size I think was 9. I don't remember. Let's see. We could validate. It's 9. There's 5. There's 9. That's actually not 9. That's OX09. Oh, yes, and green matter and that. Now it's going to tell me that the structure header size. Oh, header size. I don't have anything against Go, by the way. Um, but I think I tend to lean into Erlang, like where I would have used Go. Erlang, Elixir, whatever runs on the Beam VM. Okay, let's run that test. It should succeed. Great. Okay. You've done some synthetic tests, Rust versus Go, and they're pretty the same. Pretty much the same for back-end development in general cases. Performance-wise, yeah. Can't fight learning curve in Rust, so probably will select Golang for the same project. Yeah, that's fine. And they solve very similar problems for back-end stuff, right? Um, and there's a reason why Google worked to build Go, right? For them, it's a cost and maintenance thing. It solves a number of problems, and it does it well. Okay, so this is basically these bytes here that are read, but that 9, that header size, is that just these 9? 1, 2, 3, 4. Yeah, that's those 9, isn't it? Because what comes after this in Flash Video? Size of previous packet. So it'd be null. It looks like it gets into something else before then. Let's go back to Wireshark. Yeah, like this on metadata. That's and we didn't get past our 120 bytes yet. We have this on metadata stuff. Yeah, so we're missing something in here. All right, so FLV starts with a standard header, which is shown below. Great. After the header, the file is split into packets called FLV tags, which have 15-byte packet headers. Oh, 15 byte. Oh, shoot. I just swapped bits and bytes. 120 divided by 8, 15. So that takes us to here. Yeah, this is 15 across. Then we start here for this chunk. Okay, that makes sense. It's 046. It's up to that point. All right. We got to trim down that chunk of data. So for the header, we just need up to this point. And this one, get rid of that. And we have our 15 bytes here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's so many zeros in there. I don't want it to wrap. So I'm making it thinner. Okay. And I'll do the same thing for uh, packet header. What do we call it? Yeah, packet header. Great. We did not implement that yet. Simple try from. Oh, we need an error. All right, now going back to the little spec that we have here, a Wikipedia page. Packet type, let's say, the packet type byte of a packet slash tag header is based on the RTMP message ID byte with AMF metadata value of 18. Okay, video payload value of 9, and audio value payload of 8, being the only valid types used. Okay, so we have 3 valid values for packet type. The third bit indicates the payload is encrypted using the same mechanism as RTMP uses. Oh, interesting. However, this is rarely used due to encrypted transport such as RTMP being used instead. Okay. Hmm. 24, encapsulate flash video. 15, flex send shared object, yada yada. Okay. Do we really have to care? No, we just want to know what the timestamp is. That's really what we're getting to. Let's focus on that. All right. So we are going to return. Okay. Packet header. Let's go to packet header. What? There we go. Now we have a packet header. Okay. Let. All right, just for now. Now the first one that we come across is size of the packet. That's a U32B. Wait, size of previous packet. Okay, previous packet size. This is less than 15. Okay. Now the packet type, we're just going to copy across. This is going to be a value for payload size. UN24, big it in. So that's 24. So the first one, previous size, the type, then we have this. Okay, so we need to pad it on the left. Let's see, in this case, is going to be a 0 followed by, all right, now timestamp lower, same thing. T 8, 9, 90. That's right. Have I tried nom for parsing? I have not. Have you done, actually, byte-oriented zero copy parser combinator library? I mean, I think it'd be fun to learn nom. Scoobery doobery. Good morning. Yeah, I've been doing Rust on this channel for a year and a half, and it has been great. It has just been great. I wanted to learn Rust, so here we are. Timestamp upper. Want the spec again? That's just a U8. Okay. And we're gonna have to figure out what the relationship is between timestamp lower and timestamp upper. Oh, you did the game jam in pure Rust. Oh, that sounds fun. Oops. You definitely want to try out GD Native with Rust too? Yeah, do. It's been great. We've done some interesting stuff. Um, Font rendering, dynamic generation of floating islands. Um, all right, now we can parse it. Hopefully it parses. Assert stream. No, this isn't stream header. This is packet header. I copy and pasted the other thing. All right. Now we're going to visually inspect this and do the parsing. So the first thing we have is the previous packet size. That is 0. That's the first 4. Then we have the packet type, and that is this OX12. Payload size, that is this. I don't know. We can figure that out. Okay, we'll come back to that. And then we'll just ask this to fill in the struct fields. Come on, you can do it, I think. Can you not do it because you're inside the macro? It's going to be 0 times upper 0, and stream ID is 0. We should test a more interesting packet. We have a whole bunch. What's this one? That's an ACK. Yeah, let's just copy this as a hex dump. Thank you. All right, so what do we get? A little bit of data. Let's delete most of it. A whole bunch of it. Oops, a little too far. Okay. Oh, interesting. Previous packet size. 45? Is this even correct? That's a very large number. This is not. I mean, is. Yeah, yeah. Come on, open the calculator. Let's see. In this case, we would have where to go. Oh, that's the ACK. I'm saying this one. That seems like a very large number. I mean, what is it? E 9, 15, 4E. Oh, where's my E? 4E. 5D? The previous packet size was nowhere near that. Okay. It's just dumping data kind of randomly then? Look at the output. I'm using TCP here. Um, and that's just, I think it's going to be doing two things. It's going to be going to a buffer on the local machine that's going to have a bit more of a robust connection to where we send it Twitch. So here we have our data. It's beginning. Yeah, these packets do not appear to be broken up on the boundary of the FLV segments like this. That's a very large number, and this is supposed to be the previous packet size. So I do not think this is the beginning of it. All right. Well, we're going to push some more interesting data through it. Uh-oh. Oh, fancy. Look at that. Huh. When I tried to fill in the fields down below, it actually added them to that derive. That is so strange. Oh yes, and pack adder doesn't have those derives yet. I might need to take a quick break. We'll see. Not using this error? Oh, this error is really nice. I like this error. But that's just keeping the dependencies down. So I don't have very many errors. I mean, it's pretty small. All right. Hey, I gotta help get a goat into the milking stall. So I'm gonna take like a 5-minute break. Um, let's adjust the text here. All right, it's not gonna be 45 minutes either. So tools. Let's say 10. I'll be back before 10, unless, oh goodness, I'm gonna go see a gal about a goat. I'll be right back. All right, see you shortly. So remove the goat. Very, very timid, which is strange because all the other ones are just like in your face. Okay. That looks good. Now, how are we going to use this? Make that public. Pubmod FLV. Let's move some more. All right, then we have our arguments parse. Now at this point, we could either use that delay queue from Tokyo Util, or right now we're using an MPSC queue, unbounded one. And I think it's our outgoing that is doing all the heavy lifting here. Yeah, it's got a little funky tick. All right, so we're gonna do we want these in terms of packets? Like how do we want to do this? I think I want some sort of associated data with the packet with the binary blob. 'Cause I don't want to really touch the data. I just want to pass the data through, but have something to carry it along. What? Was that? That's okay. Oh, that's right. Now these have to be public. All right. I'm sure we'll import duration in just a little bit. Um, I think we do have to change how we're reading them because we're going to read the packet header, right? Once we have enough bytes, we'll read the header. Once we have the header, we'll read the rest of the data. Create one of these, resize it. This still doesn't seem like the right way to do it. We'll see. 'Cause I don't think we should be resizing, but I need to take ownership of the data and pass it to something else, which this wouldn't work for that. Okay, we're not going to need the bitrate, are we? Hold on, let's go back to arguments. What are we going to need? We're going to need the delay, but not bitrate. So let's get rid of that. Goodbye, bitrate. Okay. And I think we're going to be passing something else. It's going to be, I think this is going to look like a packet header with bytes associated with it coming through. Something like that, some little tuple. Actually, I want to do an FLV packet header. I want to qualify it. I like how that reads better. No more bitrate. I want to know what the expected size is for that packet. So let's go back into FLV. I want to impl stream header. I just put a static on it. Or just a function. It's supposed to be 9. But what type of 9 is that? Is this a U size? Probably. Public. All right. Let's take a peek at the docs on this one. TCP stream. I want to know if it has so many bytes for reading. Oh, you know what? We can just read all. We'll read all. And we have two sections. We basically have the first header and then all the packets. Nine U8s. Oops. Read exact. Header there. Dot to wait. Great. And that needs to be mutable. Okay. Get rid of that. Expected mutable reference. Oh, almost got it. There we go. Now, does that tell us anything interesting, or does that just get us past it? We might have spent a little too much time parsing that. Who knows? Maybe we'll want that. Because, I mean, we didn't use that at all. And I don't think that we actually need that data. Oh, I should have thought of that. Yeah, no, we don't need that at all. Okay, fine. We kind of do. Let's use it to verify that the header is what we expect it to be. What do we call it? Call the stream header. Okay, that should at least tell us whether or not it's correct. And we'll parse it. I don't know, just we can call it header again. This technically isn't used. Get rid of that return. Okay. Add header. And we have bytes here. And we have to know how large of a payload's coming so that we can read into that. Is it payload size? Size of the packet data only. Yes. All right, so we made those public. We can access them now here. Get the buffer, resize the buffer, read that, and we have to send header along with the bytes. Packet header and bytes. Okay. Now send outgoing needs to change its type. There we go. Packet header and bytes. And now we can start looking at the timestamps. So we're going to want to wait to send things. So we need to know when we first got data and what the value was, and then we can adjust based on that. We need three things, don't we? No, two things. Two things. Just one moment, please. So we have the packet header, we get the bytes, and we send that out. Now here, dbg, packet header. Let's just see if we can get. All right, connect 127.00.1 port 45123. That's going to be netcat. Hmm. That we should describe what the value is. How many seconds the data is delayed for. Now this actually waits. Okay. Oh, look, we got the netcat garbage at the top there. Netcat-L 45123. It's just going to receive all the garbage. Let's also do a hex dump -c. Sure, why not? All right. Now we could connect to this from OBS using our start recording button. There we go. The timestamp here is interesting. Oh, what? You thought it was on early. You just lost track of time. Oh, that's funny. All right. I'm not sure. Okay, let's figure out what timestamp lower and upper does. Actually, let's see. Yeah, it's sending data to this fairly quick. So my machine, you having issues, buddy? Okay, we're just gonna stop it. That closed, broken pipe, came back to OBS. Perfect. So if something goes wrong, I get alerted. Alerted. All right, but timestamp lower and upper, I need to know what that is. And 4 bytes for the timestamp in milliseconds, with the last byte used to extend the first 3 bytes. The next 3 bytes for the stream ID. But how does it extend it? Oh, hey, CM Griffin. Well, thank you. Thank you for that, man. And congrats, 715209. Yeah, so today we're working on kind of a I don't know, a stream fixer for Starlink because I have really great speeds, but occasional respect the packets going through. Have some moderate buffer. It's going to it's going to end up um, adding some sort of delay to this, right? Whatever we add in the command. Um, but then when the network comes back on, it can upload very quickly, right? I can get like 20, 30 megabit per second upload sometimes. So we just hit it again with a lot of data. The buffer is full, and we're just trying to get that little bit of sponginess in this, so that Starlink doesn't um, drop so many packets here. But the last byte, 8, H263, interesting. We see packet type here. Mm, Video processing parameters. Let's see. And how does it need to extend the fourth byte? Last byte used to extend the first 3 bytes. Oh dear. Video file format specification version 10. All right, let's I clicked it. All right, oops, time. Oh, this is FLV box definitions, file format, simple data types, handling of unsupported types. Okay, maybe this on line 3 or page. I think RTMP and Rust. Yeah, I just need the timestamp, so I'm not using the other crate. I just need to know what the timestamp means. So here's the data tags. We're skipping those. Okay, let's go to, what is it, 68 here? Yeah, we don't have to worry about encryption. Where's page 68? Oh, we can go there in the top here. 68, enter. Wait, maybe 68 isn't the real 68. Oh yeah, it's 4, 5, 65 here, 66, 67. We're getting close. Audio tags are present, shall be 0. Video tags are present. This actually reads a little bit different. Ooh, a joke. What did the janitor say when he jumped out of the closet? Supplies! That's. Oh, thank you, 715209. Let's see. Yeah, I'm looking to answer the question, what does the timestamp lower and upper, what is the relationship? I mean, is it timestamp upper just the high byte of this? If so, that's easy. I just want to make sure that's the correct answer. Okay, so if we go into time, RTMP timestamp, no, time, referencing their number of milliseconds from an unknown epoch. Times are adjacent if they are within 2 to 31 minus 1 milliseconds of each other. Wow. I'm guessing that it's just going to be the high byte, We could probably do that. All right. I didn't see the parse in here for creating this. Yeah, it just gets a U32. So where is the RTMP timestamp created? Let's go back to the file you showed us. That's a message payload. That's 0. Here, it's being passed in. All right. I'm going to go back to the doc. Hopefully it'll just say extended. Okay. Time in milliseconds, at which the data in this tag applies. Value is relative to the first tag in the FLV file, which always has a timestamp of 0. Got it. Extension of the timestamp field to form an SI32 value. This field represents the upper 8 bits, there we go, while the previous timestamp field represents the lower 24 bits of the time in milliseconds. Why would they separate them? That is so strange. Unless it was reserved, like, we might need this later. Here you go. All right, so in our parser, let's just fix that. It'll just be milliseconds. Bub's timestamp U32. Yeah, I mean, okay. Which means that if we get the bytes for the because technically this is value 11 there. Okay. Okay, there we go. Now we have the correct timestamp, which is the number of milliseconds since the stream began. So we need to know when that instant is. Send it out at the appropriate time. Okay. Okay. Going back to main, we need to know exactly, well, roughly, exactly. We need to know roughly when this is. So we wait for a connection here. And we can say now stream start time can be instant now. Now. There we go. Then we can pass that into the send outgoing. Oh, we do not need this sleep any longer. I know it. That can actually go inside of send outgoing. And then we just delay this by however long we need to. So args delay. Do we want to convert that? Change it to a duration? Because we're going to have to. And we just deleted that sleep. What does that sleep want? A delay. That's a duration, isn't it? Yeah. So we need to know how long to sleep for. Okay, with that, now we can look at the packet header, wait so long from, goodness, we have the stream start. So let's answer the question. When, let's say packet is sent, stream start plus, hold on, um, Tokyo time sleep, whatever our wait is. Okay, and let wait. That has to be a duration. That duration is going to be, I'm stretching. It's going to be some small value, like milliseconds, etc. Now minus stream start. Let's delay. Packet time, right? Because that's milliseconds. So it's basically that instant plus this plus delay. That's when it needs to go out. And then the wait and when minus now. Okay. Thank you, 71529. I am still waking up today. All right, so when is going to be equal to, let's see, we have, how many different types do we have? We have three different types. We have an instance, U32, and a delay. Because an instant, we can subtract it from, we can get the change in time from those two. So we can know how long it's been since then, which is basically now. So it's going to be instant now. And we can get the duration since then. But we can't really get much else. We can do a check to add. We can add a duration to that. Oh, interesting. We can add a duration to it. Okay, well, if we can add a duration to it, let's do that. So stream start plus duration from millis. This is going to be packet header dot timestamp as U64 plus delay. Okay. What is a good way to pass around state, which can change at some places? Would I just use an arithmetic state? Are you multi-threading? Because you might not need an argmutex. Um, but multi-threaded, yes, that'd be a way. And there are different crates out there that you can use for the mutex. You don't have to use standard mutex. You could use like parking lots mutex, or if you're using async, you could use Tokyo's mutex, etc., which really aren't mutexes but are backed by something else. You're using async Tokyo, yeah, and it's multi-threaded. So yeah, arcmutex, a faux singleton, like a one cell. All right, we await the sleep. Does this return any other value? What if we give it a negative value? All right, well, this might be it. Let's see. And there's that one, this one. All right, let's get to OBS and start recording. Oh, supplied instant is later than self. 281. 281. Oh, in standard time. Uh, all right, let's run that. Run that again. Okay, recordings. We're actually going to output to a TCP stream. So we're going to have this flash video file, which is this stream right here, outputting to some sockets, and we're writing some software to be able to smooth out those bumps like the one that just happened. So we're going to hit start, and I want to see that stack trace. Which one was it? Let's see, 28. 28, really? Oh, no, 50. I missed that one. So now, yeah, let's test that. So I wonder what that value is. 'Cause it doesn't seem like it's backwards. That's in the past. Why is that in the past? It's gonna be the stream start plus the number of milliseconds plus the delay. And the delay should be in seconds, right? From millis. Ah, okay, now that feels like it's more correct. However, it doesn't. That number should still be in the future, at least a little bit. Oh, well, stream start. So that's this value here outside of the loop. Then we have the timestamp from the packet, which is the number of milliseconds since from the beginning of the stream, right? It's just from some random zero, right? It's from whenever we hit the button, and then plus the delay. Okay. like Linode, some little $5 a month thing. Okay, now let's hit the button, start recording. Boop. Oh, look, now it's waiting. And then it went, and then it died. Because sleep wants a duration. Hey, Wackiator, how are you? Good morning, and welcome. So we can see that this and that now is later than when. This value should be past this value. So we did the sleep. Okay, let's work through this. We had the packet header come through. We measured the instance, 77, 79. But is that correct? Because when is supposed to be in the future, right? So that's supposed to be the big number. Minus now, which is the lower number, should result in a positive number. I mean, what's wrong here? I mean, what are we not seeing? The stream start plus the packet time plus the delay. I mean, here, where Tokyo time? I think there's a different function we can use. Sleep until. We can give it an instant. We can say sleep until that moment, which should be when. What was it? Oh, sleep until. Until. It wants the other kind of instant. Oops. Get set up, try it again. We should see a 5-second delay at the beginning from hitting the start recording button. In 3, 2, 1, boom. 2, 3, 4, 5. Lovely. Okay, that looks like it's working. All right. So we've got that. That's working. Now, all right, get that pushed. Oh, bad credentials. I did reboot. For the stream to recover. Or, maybe we make it 10 or 20, whatever it is. I don't want to go higher than like 5 if I have to. I just want to smooth out most of these issues. And thus far, like all of my like SSH connections and stuff like that always last longer. Okay, now let's go to the box. SSH to Pinky. Wait for it to get pulled. How do I know if the packets are sent? Um, like here, the packet should be written to. And basically, if anything in the pipeline fails, then OBS will tell me that, hey, something died. So kind of like one of these errors, OBS will say this didn't work. But we're going to leave it. We're basically going to send all the packets across the shaky network, right? Actually, it's very fast, very good. I like Starlink so far. It's just this one thing I don't like about it. Um, so we're going to be bridging that gap. So all packets made across there, and then FFmpeg can take it over from there and send it to Twitch. Okay. Sorry, was that a git pull? Is that what we did? Yes. Cargo install dash dash path. Then we were going to do an SSH to that box. SSH dash L. So we're going to create a little tunnel here. 45321 to 127.0.0.1. Then on the other side, 45321, the port. It's basically going to open a connection, um, a tunnel on port 45321 on my machine here that OBS is going to send to. Right, so the left side there. Then on the remote side, it's going to connect that to whatever's listening on this port, which is that software we just made. So like this, we no longer have a bit rate, like so. And then this is going to connect to something else listening on a 45234. And due to credentials, I can't show that on the screen. So let me move that. I can open just some other window. But basically, I'll copy paste the command without the credentials so you can see what it is. Basically, we're doing something that looks like, oops, Does that not work? Well, it's basically, I could have typed it faster. Listen one dash I, then we do a listener here, TCP colon slash slash 127.0.0.1 colon 4532, no, 234. It's not going to be doing any transcoding. It's going to be using the packets just as if, oh yeah, which, mm, I kind of get tired of having to deal with the issues on when I export this to YouTube. I think we might be able to bring the music back. We'll have to see. Let's see. Yeah. Boop. Huh. If I click on that, it doesn't go away. Oh, there it did. Okay. So then we have the codec, copy, because we're just sending the bytes right through. Really light process. FLV, and then RTMP colon slash slash Twitch. Right. This is basically what's running on the server. And that'll be sending to my mule. Okay. What? Oh, okay. I've got the FFmpeg proxy running. We've got this running. Now all we have to do is tell OBS to stream, and then that's going to go to my mule. I've got a test account. Start recording. Uh-oh. 45321 refused. Oh, we didn't connect. Pinky. Oh, let me log into this other box real quick. Okay. So we have the tunnel up. Gonna start recording now. Okay, so far so good. Uh-oh, connection reset by peer. Invalid data found when processing input. I can show you this part of it. But FFmpeg failed. I wonder why. Did we omit something? We didn't send the header through, did we? When we read the incoming. Yeah, we never send this through. It's like, I don't know what this is. Yeah, we didn't take care of this part. Oh yeah, do we need to send audio copy? No, it's all already there. We're not going any further than just looking at the timestamps. So in this case, read exact, try from. Yeah, we just have to send those bytes. Um, shoot. Is it always the same? No, we do need the other values from that, don't we? So the problem is that here we have this packet header, right? We're saying it's this kind here, not it's one of these two kinds. Because if we did want to send tx.send, header, and then whatever the bytes were, actual values, yeah, we have to do exactly the same thing as below. Uh, we're going to get rid of that header there. We're actually stripping out the headers, all of the headers. Okay, let's reduce this to a timestamp. So basically, we'll say that instead of a packet header being sent through here, we'll have just a timestamp, which is basically the U32. Oh shush, it's all freaking out. So in this case, uh-oh, OBS, yes. Okay, file header. So we have to send these bytes. Problem is, I need them to go into bytes for one thing. Can just say this is the header. Get rid of that one. Now we want to read exactly that header. I think there's on bytes like a as mutable slice or something. Yeah, it looks like we should be able to do that. Okay. It's hard to tell with all this garbage going on. All right. So send in this case is going to be the timestamp, which is always 0 for this. 0. And then the bytes. Bytes not freeze technically. Expected value found crate bytes. Oh, because we didn't actually read. It's actually called header. Ay. Can I just send the bytes I read? No, I also need to know when to send them later. Because right here we're filling the sponge, right? This buffer is a spongy buffer. Um, because sometimes it'll get a little dry, and sometimes we have to fill it back up. And because of that, we can't just send the bytes because at the far end of this is FFmpeg, and if you just slam FFmpeg with a bunch of data instead of data at the right time, then it's going to start playing things back faster or slower. So we want it to go right. We have to send the bytes for the header. Oh no, this is the header at the very beginning of the file, but then for every single chunk in here, I forget what they call them. Um, Adobe calls them something else, and Wikipedia, which was back here a little ways, calls them packets. So yeah, we have the header for the file, and then a header for each packet. Oh no, no, this one does. This one does. With capacity, and this was 15. Then we have to resize it, and I forgot to resize this one. All right, then I can fill it. We can use it, send it. Good. Now for the next section. Okay, I think that might be it. Ah, and then where we send, this also needs to be now a U32 because we're no longer getting the packet header, we're getting the timestamp for that packet to go out. Any other warnings? Yes, one there. Okay. Now we could test this here, but where's the fun in that? Let's just commit it, send it, run it. We'll test it in production. Oh, look, payload size. That was wrong. Should be 273. All right, that should all be fine now. Um, we're going to test in production, people. All right, surprise me. Well, that makes the best streams, right? We'll just write code that could go terrible. Now, what's our commands from before? Gonna run that. Wonder. So I want to do that a little different. We're gonna disconnect. We're gonna come back over here, and instead of this, hit cancel. Pinky. We're just gonna run that command on Pinky. Do I need that in quotes? Looks like it's okay. All right. And I've got, no, this one, not my favorite. I've got a little kind of salsa. Oh, oh, the audio on it. The vocals. Um, Now we're gonna start recording. Ready? In 3, 2, 1, boom. And it died very quick. Why did it die so quick? It's like no errors. Okay. Maybe testing in production was a bad idea. Um, yeah, we're gonna do that. Start recording. Connection refused. Oh, it's supposed to be going to 1, 2, 3. I mean, it's working. Okay. It almost just worked. Oh, that's right. I'm guessing um, that I'm actually missing something in here. Like something is being omitted. Because, oh, you know what we could do? Here. No, not that button. This button. If I change this, here, I'm going to take a screenshot of this. All right, copy that. All right, output to file. Sure, movies. it's actually not going to change this. So we're going to do this a little different. We're just going to listen on that and dump it to file. Then we're going to do some other tests. Start recording. Okay. Netcat dash L45123. I'm going to pipe that to, um, wait for it, test.flv. Okay. Now we're going to start recording. Oh, it's 45321. Unspecified error occurred. Why? I mean, that worked. Okay, we can cat it to, yeah, no. Test.flv. Can we just pipe it to a file? No, we can't do that. I mean, this I thought, no. It needs to go this way. This is, it's weird, but I think that's not. Right. The file is has no bytes in it. That's funny. That's funny. Welcome back, OBS. OBS just wanted to take a nap. Just want to make sure that we're sending all the data out that we receive. Header, yes. Read exactly into that. It's 9 large. That goes at 0. All right. Now this one, read into header bytes. Then we send header bytes. Fine. That looks okay. What's wrong in this? What is wrong? I'm guessing that there's something wrong. Just going to run it again. I want to see the error. In 3, 2, 1, go. Stream just came back. An error occurred while recording. Yeah, see, we get this error. So the connection was reset by peer. I wonder which one. Ah, shoot. I got to reset that mule. Just a moment. Where's our stream manager? Settings, channel, and this is how you reset the stream key that you just leaked on stream. Done. Okay. All right, that's fixed. Now, come back to string manager. Oh dear. My mule's getting followers. Don't follow the mule. That's just funny though. That's fine. Um, I actually wanted to go to this page here. It says it ran for 30 seconds. Well, not much data. Zero plus pretty much now. Basically no duration plus the delay. So when it should be delivered at. This is just sending data pretty straight through. It feels like I have like a size wrong or something. See, that's what I was trying to do when I was trying to write the file to disk. Let's see. Is there like a test FLV file? All right, we want something tiny. This one's 2 megabytes. Sure, let's just download that. Anything smaller, 1 meg, because it does not have to be large. All right. And what was that called? That is called sample video. source Rust. All right, so now we have a sample video that we should be able to pipe into it using netcat, pipe back out, cargo run, like so. So we need two netcats, one to feed it, one to receive. Let's set up the receiver, netcat dash L, and it's going to connect to 45123. Output dot FLV. Okay. Now netcat dash, let's see, 127.0.0.1.4.5.3.2.1 sample video. That's it. It's like done. Oh. Okay, it finished running. It did. Uh-oh. They're the same. Oh, no, no. They differ by 4 bytes? Really? Is it bytes at the beginning or the bytes at the end? I don't know if I have. Where's output? I don't know if I have X. Oh, I do. Okay. That's quite a ways into the file. Uh, and where's this in terms of? Okay, but that's at the very end of the file. We didn't actually get to the end of the stream. So something else is agitating it. Maybe it's because these are not. Hmm. What's another way to do this? Um, that last little thing at the very end of the file, I'm guessing I just didn't implement like whatever it was, some other packet or something. 00. Yeah, there's probably something that I just didn't implement, but that's okay, mostly, because the very end of the stream, If that fails, fine. We'll get to that part and fix that when we get there. Um, sorry. So then what was the issue? Because it was saying something about not being able to set the file head. What was the error again? And this time we should save the error. Okay, we're gonna run that. Need to run the let's see, ffmpeg. Yeah, that's running. Let's try to do this. That's going to the SSH tunnel. It's going across. Oh, it's just working. Why is it working? You know, OBS did crash earlier. Encoding overload. Oh no. All right, we are getting a little bit of encoding lag. That's okay, because this whole system should help smooth that out. All right, I want to go back to this because we're going to compare this with mine that's going on right now. I'll pull that onto the stream. It's over here. All right. So you can kind of see the two here. I'm still going. Let's jump in a little bit. Try to get them equal. See, we're 5 minutes here, 1 minute on the right. It's lagging. Um, how do I make it faster? Code list. Oh goodness.